be talking about storage, specifically AFS-based storage and software deployment onto and with AFS, both AFS-aware software deployment and AFS-unaware software deployment systems. So for my bio, I joined Goldman Sachs in January of this year. I'm in Unix engineering. Previously, I was IT staff for Iowa State University, where I managed the AFS infrastructure for about 20 years. I used the AFS there. It was used for software deployment, scratch space, home directories, and backing a lot of the services we had in place. I also handled Kerberos, Splunk, identity management, etc., whatever else came up. It's also a NetBSD and package source developer and an OpenAFS contributor. I helped port the OpenAFS server to NetBSD. I stress test both of those with package source and ran them in production for quite a while. I have been a co-organizer for the AFS and Kerberos best practices workshop and occasionally presented. One of my favorite presentations that I gave with a coworker was NetBSD, AFS, and Kerberos from zero to distributed file system in N easy steps. And I'm a Doctor Who fan, which is where the title of this came from. The TARDIS is a police box. It's been hidden by a perception filter in the newer series, and so it's not noticed by random passers-by. It contains an infinite number of rooms, corridors, storage spaces, closets, and a pool or two. So bigger on the inside is what everyone says when they walk into the TARDIS. Or rather, it's bigger on the inside. Much like AFS, people don't notice they're using it. They don't realize it's there. And so a lot of the end users of AFS never realize they're actually using it. We're going to talk about what AFS is. So AFS is a general purpose network-based file system. It has clients available for Windows, Mac OS, Linux, iOS, Solaris, and other Unixes. On an AFS client, it just looks like a local file system. It has location independence and global file namespace, which gives you reliable access with or without replication, even during maintenance operations. AFS clients and servers together determine the mapping of where a file object is stored behind the scenes. The path to the file does not change when you're moving a volume from server to server. The AFS user does not know where the server serving a file is located and does not need to care. An AFS cell is a unit of operation. The AFS cell is a server and its client hosts in combination. The servers provide a distributed object service where each AFS volume is a distinct object store. The contents are used by the client cache managers to construct a rooted directory tree that looks like a normal file system. AFS clients cache their data locally. It requires that the data be read once over the network for each data version, but then everything operating on that data happens locally, and so it's happening at local disk speed. Volumes can be replicated across multiple servers. Now, these are read-only copies, but this allows redundancy, easy failover, and in case of a server failure or you need to take a server down for maintenance, all of the read-only copies on other servers are available for continued use. There's a lot of security features that are available with the client and server implementations, but which ones you have available depend on which clients and which servers you are using. Orastore Incorporated's version of the file server is backward compatible with the pre-existing OpenAFS clients that we had been using for a long time. So we were able to switch very smoothly, and Orastore scales better and has made many improvements over what OpenAFS had itself. As I said, I'm going to try and pause a little bit for any questions. I have an abbreviated history of AFS. AFS was originally developed at Carnegie Mellon University as a file system exporter, which is what you'll expect from an NFS type host. It was called the Andrew file system after the Andrews, Carnegie, and Mellon. Version 2 switched to the object store per volume model. Version 3 was deployed as part of Andrew, Project Andrew, which was funded by IBM at Carnegie Mellon. MIT used it as part of Project Athena, which some people might be familiar with. Iowa State University used it as part of Project Vincent. It was a reasonably common part of a distributed computing in an academic setting at that point. Andrew file system was renamed AFS by IBM in 1989. In 1993, the Arla project at KTH in Sweden started the BSD3 licensed AFS v3 implementation. I used it to provide backend storage for Majordomo and Mailman archives and file store for the central IT web servers. It was the only client available for NetBSD at the time, so that was what I was using for that, as I was using both in production. In 2007, Orastore was founded as Your File System Incorporated. In 2017, Goldman Sachs replaced the OpenAFS clients we were using with Orastore FS clients in the general release and deployed it to 25,000 hosts at that point. And then we've grown since then, of course. So what do we use AFS for? We use AFS to provide software distribution at scale to hundreds of thousands of servers deployed throughout private and public cloud, managed by separate units independent from the AFS engineering team. AFS allows the distribution of tens of terabytes of software to these clients using less than 10 gigabyte of local space on each, with close to the speed of local disk, supported by 3 to 5 AFS servers per cell. It also allows us to have a consistent space across everything that looks the same no matter where you are locating your cells. So we use AFS for the sub-minute software deployment. It gives us the ability to deploy read-only volumes with new versions of software atomically, maintaining consistency. Network writes to the read-write volume happen over time, and related changes all become visible to the client systems through the read-only volumes simultaneously, so that the writing is invisible until we release the changes. Our monthly patching reports show that we're deploying to upwards of 100,000 client nodes running Orastore FS every month. Majority of our clients are enrolled in monthly patching, some are not. So we do have a few older versions of the software as well, but most of our clients are running Orastore FS. Our software deployment methods provide somewhat under 30 terabytes of software to our clients. That is both AFS aware and AFS unaware software deployment methods. Our clients are set up to have a 10 gigabyte cache on each client, where the client accesses the range of file content. Only the content that they actually need is cached to their local drive, so we can end up with a larger amount of binaries and libraries available than you may consider, given we do not have to cache complete files all of the time. And it reduces our network traffic and our local storage requirements. It also allows our 3 to 4 servers per cell to easily handle the 15,000 to 30,000 client systems that are part of each cell. Our AFS servers are deployed on commodity hardware or in cloud-hosted virtual machines. The commodity hardware just uses locally attached disks, and the cloud-hosted virtual machines are fairly standard cloud machines. We have this all designed to accommodate AFS server failures without client impact. Location independence allows management and maintenance of the AFS server structure to be generally invisible to clients. And the global namespace gives us easy replication through all of our mini isolation domains with management and audit requirements that can vary based on the region or legal requirements of that area. This is somewhat of an awkward silence, but I want to make sure I'm leaving a little bit of time for any questions that may come in. Certainly questions at the end are welcome as well, however. So we started deploying Orastore in 2017 with 25,000 hosts. Now we're at over 100,000 clients running Orastore FS that are patched every month. And the reason why we went with Orastore is because it was backward compatible with the previously deployed OpenAFS clients. We had been running OpenAFS for years, but we got a significant speed increase with deploying the Orastore FS client. There are significant speed increases that because Orastore FS can serve over 8.2 gigabits per second over per RX listener thread up to 16 threads, where the hardware and the OS permit. OpenAFS 3.6 could handle 2.4 gigabits per second, and they can only handle one RX listener thread. The RX listener thread is really what's doing all of the network work. Orastore FS also has much finer grain ACLs that are not part of OpenAFS. OpenAFS's ACLs are based on a directory structure, and the ACLs are entirely per directory, they are not per file. So you can do them on files, directories, symlinks, mount points, where as opposed to, and there is finer grain access control on the volumes. We can also do volume-based security policies where volumes can only be read in a properly encrypted setting or written from properly encrypted settings. And we can also have file server-based security policies. Orastore FS also gave us uniform audit streams for all server requests, so we can audit everything that is changing across everything on our AFS servers. Orastore FS also gives us AES 256 CTS HMAC SHA-196 and AES 256 CTS HMAC SHA-512 384 encryption, which can be used for per packet integrity protection and wire privacy. It's a significant improvement over what was available in OpenAFS. And that's a critical feature for us when we're working on things over a wide open internet. Orastore FS also provides better handling of out of order packets. It deals better with any network congestion than OpenAFS was able to. There's a number of other improvements, including the number of volumes per cell and the number of objects per volume. Some of the improvements are not available where we've had mixed clients. Several of our recent deployments are Orastore only. So our AFS infrastructure consists of tens of AFS cells, each with 3 or 4 object or file servers. Each cell can support tens of thousands of clients, but in some of our busy data centers, we'll have more than one cell to serve data to the clients to give us some redundancy, in addition to the redundancy we already have with the individual AFS cells. Some of our cells are AFS aware software distribution only. Some of our cells are AFS unaware software distribution only, and some cells have both. Each cell has a single AFS aware or AFS unaware writer on their client host. Our current AFS usage is overwhelmingly read-only. The AFS aware or the AFS unaware software deployment writes their copy of the software into AFS. The end users are the overwhelming majority of our AFS users. The major part of what makes this work so well for us is the read-only replication. Read-write volumes are replicated into the read-only volumes across the designated servers for redundancy. This means that we have multiple consistent copies of these software packages available across the entire cell, even when a server goes down. The process of replicating these volumes is called a release. Once it's replicated, the read-only and the read-write volumes are the same for that point in time. Releases are incremental, so if there's only a minor change in a volume, it is a very quick release. If there's a larger change, the change can scale for the amount of data that needs to be transferred across the network. The AFS servers are copy on write on the server. So a read write to read only clone on a read write server is effectively instantaneous. Volume version changes deploy in seconds for small volumes and small change sets. And the servers establish volume level callbacks for read only volumes with the client for the active files that are in their cache. That means that when there is an update, the server will notify the client that there is an update available, and the client can then refresh the cache, the portions of the cache that need to be refreshed. Excuse me. So bigger on the inside. AFS aware and AFS unaware software deployment are both steadily growing, serving internally and externally developed software. Our AFS standard client size, cache size is 10 gigabytes. It's filled with the pertinent software binaries and libraries for what the client is in production to do. The AFS clients provide access at local disk speed to the needed software. And the needed software for any particular client can vary. It depends on, we have tons of software available. We have terabytes of software available. And each client can use a different portion of that set. The set that a client is using is called a working set. And as long as the working set for a client can fit in within the 10 gigabit cache, the access to the file chunks needed to provide the pertinent software binaries and libraries works at disk speed. An important goal for AFS is to avoid the expensive network round trip to the file server. As much as possible, we want to never have to go back to the file server except to validate changes or to update invalidated cache items. One of the interesting features that we saw is when we deployed to the cloud initially, many of the clients were actually still referring to the data center AFS servers. And the traffic was still contained enough to only be noticed by accident. So even though we had many clients deploying into the cloud, those clients, while they should have been talking to the cloud file servers, were actually talking to data center file servers. And yet the amount of traffic, because of the caching, was so limited, it was only noticed accidentally on a further review. This allows us to provide hundreds of thousands of hosts that perform business functions to the firm at close to local disk speed without repeated, possibly expensive, unnecessary network usage, and with a standard small disk allocation rather than more expensive larger disks. As a Doctor Who fan, I consider this our version of the TARDIS, bigger on the inside as it applies to AFS. So for our AFS aware and our AFS unaware software distribution, both of them are deployed out of a master repository to the AFS cell writers, where the content is written into the AFS volumes. But they do it differently because one of them understands AFS and the other just treats it as a local file system. For the AFS aware software distribution, each package is written into a separate read-write volume created by the software distribution writer. And that's each version of each software package. So if you're dealing with GCC 3.4.5.6, that is the volume for that. You don't have a GCC volume necessarily, although that could be a path volume. You have a version volume, and each package version has its own volume. The software package volumes are static once written, so they are only released once and there are no modifications to that volume. That means for our end users, once the volume is written, they can depend on that not changing until it's removed. It only needs to be released once. It is immutable. The writer, the distribution writer, performs a release when the package writing is complete. And the writer itself is AFS aware, so it monitors the AFS server partition free space. The parent or path volumes are effectively used for mount points for the volumes that have the package versions in them. The parent or path volumes change with new package versions to host the mount point for the new volumes. So those have to be released with each new software version in their path. But because the volumes written are small, both the parent or path volumes and the package volumes are all small, and they're released only once for packages and released as needed for path volumes, the times to release are quite fast. That can make software available across the entire infrastructure worldwide in minutes, as in under 5, depending again on the size of the software being written. The AFS unaware software distribution can take a little bit longer. Because it is unaware of AFS, it is just writing into a file system. The file system hierarchy is already laid out with a few path volumes and a few very large software volumes. The volumes are not static and they're changing with every new package update. And so with the continual changes, we have to watch and monitor for these updates before we can release the volumes. We are still using read-only replication for this. It just requires monitoring to know when writing has stopped. Copy on write on the file server means that changes to the volume take up additional space. The read-only volume and the read-write volume are the same when the release happens, but changes to the read-write volume cause those volumes to change and to be different as writes continue. And the longer the time there is between releases, the larger the change set is for that release. If there are large amounts of changes and you're running close to the partition size, a large change could fill up the server partition. We have software that we run on the AFS servers that monitor for pauses in writing. But because we are continually writing, sometimes it can take longer than we would like between releases. We perform our releases when the volume requires an update. So we are continually checking to see that the read-write volume has a change. And we also are monitoring to make sure it's quiescent because we have to have writing stopped. If writing is not stopped when we do the release, it can be a partially written file released where a file might have been deleted to be rewritten. A file could be being changed, and so some portion of the file could be inconsistent. Or there could be other issues just because not everything, not all of the binaries or libraries that are needed are in place. So we take a huge amount of care to prevent the release of inconsistent volumes. The AFS unaware software distribution is actually working towards becoming AFS aware as well. That's some progress. That's something that we are currently in progress on, as we've been working on that for a little while. And here's the point where I want to know what your questions are, what I can help you with, anything I can answer. I would appreciate any questions.
So go ahead and feel free to put your questions into Slido. Got a little while before we all have to head out. And while people are thinking about their questions, one of our participants, Jerry, has asked us to mention that he is giving a talk at 5:30 Eastern Standard Time, 3:30 Mountain Time, talking about understanding Kubernetes storage, zero to writing a CSI driver. So if you don't have plans for 3:30 already, Jerry's talk is there.
Even if you don't have questions now, if you do have questions later, there are certainly active forums for AFS, and all of the people who work on AFS are easily found, as am I.
Tracy, do you have a couple like resources that people can use, or directions to those forums that they could join?
So the Aura Store, aurastore.com, hosts actually the binaries used for the Windows client, and the Mac client that I use for AFS on my personal servers. I actually run it AFS at home, also Kerberos and other fun toys. There's also OpenAFS, openafs.org, and that has been where links, for example, to the conferences have been. And there's a few other places like that. There's also a set of mailing lists for OpenAFS. Aurastore runs their own lists as well, and they have announcement lists for new clients when they're available.
All right, we do have a couple questions, Tracy.
The
first comes from Kevin. So he asks, what does AFS aware software mean? If AFS appears as ordinary disk space, why is awareness needed?
So it's AFS aware software distribution. AFS aware software distribution is the writer understands AFS, can control writing the clients, writing to the volumes and releasing the volumes. And it allows us to break things up into small, easily handled chunks. AFS unaware is the software deployment writers just write to a normal file system, don't understand anything about AFS, and just works. I can expand more if that helps, but this is all about the deployment of the software, not the software itself.
Okay, great. Another question that we've got comes from Jerry. Any plans to use RStore FS for data sets, for example, machine learning?
So that's been an interesting discussion that we've been having about talking about whether we could use AFS to provide dynamic scratch space. And I have used it for data sets in my previous position. And I know one of the important things that we were considering is how we could use that with various things coming in the physics networks, coming over from the physics researchers, because they're large, they have fairly large data centers. I also know that some very large data sets are stored in AFS from some of the major energy laboratories. That's actually been a fairly huge usage is by the physics and other big laboratories. I know CERN has been using AFS for a long time. I know that Stanford's linear accelerator was using it for large data centers. As for us, our current deployment is strictly read-only. There has been some interest in read-write access, but that is a different style of deployment, and we would have to work on that as a separate project.
Okay, another question for you, Tracy. How many cells do you support?
Currently, we have at least 65 cells. We're in the process of adding more. We have several in the cloud. We have at least a dozen that are deployed in the public cloud spaces, if I recall correctly, and then our other cells are deployed in data centers around the world.
Okay, another question for you. Is AFS particularly suited for a certain use case, or should it be avoided for some use cases?
Let's see. So I think for most of my use cases, I think AFS works really well. The one use case that I am aware of that might be more difficult is backing a database. And even then, I would want to check with Orastore with what's possible today. I know that we've used it to back Major Domo, Mailman at my previous position. We used it to back web servers. The web servers were for clients who ran, who had in their individual home directories, their own web directories. This was a while ago, but everyone could have their own web space running out of their home directories, and the AFS was just updating whenever they changed things. They didn't have to log into anything special. It was just part of their home directory available everywhere. But Iowa State was also doing replicated read-only software distribution when I started there more than 20 years ago, in order to provide Ultrix servers with more than the 125 meg of disk space that they had available. But for most other uses, I think AFS is suitable for almost everything. As I said, databases where you're doing row locking and needing to insert might be more interesting. And I would again talk to Orastore more about what's possible there.
These have all been really, really great questions. One note from Jeffrey, he's noting that you can visit the hashtag BMDD_RStore channel if you want to chat more about this. And also failed to mention that Jerry's talk that's happening at 3:30 p.m. today, Mountain Time, also discusses AFS and RStore. So if this topic is right up your alley, we've got another event for you to attend. Any other questions that we can answer for you?
I would certainly advocate for attending Jerry's talk, because it's actually really fairly interesting use case for being able to plug AFS into the into Kubernetes itself. So.
Okay, if we don't have any other additional questions, oh, we don't have a question, but a comment. Kevin wants to say thanks. So, um,
One thing I didn't mention very much in one of the interesting things is the kernel AFS client that is available allows you to start playing with AFS natively in Fedora and at least one other Linux release. I forget which one. Sorry, I don't have that handy right now. So that if you're interested in using AFS, it might be something if you can talk to, if you have servers available, you can use it as a client natively in Fedora.
thank you, Tracy.
Mhm.
Um,
I
if
appreciate everyone's time today too. I did want to make sure to thank everyone who attended.
Yeah, we know with this being virtual, it takes, I think, almost a little bit of extra effort to make it. So we're happy that everybody was able to attend. Tracy has graciously said that she will be hanging out in the room 4 Slack channel until about 12:30 or so. So if you have additional questions in the next 20 minutes, feel free to pop over there and she'll be able to answer them for you. I think if we don't have any other immediate questions or comments right now, we can wrap it up.
Thanks everyone. See you in Slack.